Hello friends, so today I will be walking you through one of the first programming language which were used in the PLC world as ladder logic programming. So this particular programming language mostly resembles with the relay based, where we have the contacts and all. And why it is called ladder logic? Because when we write the program between two rails, it forms a ladder form. So let's start how we can define that in the CoDeSys. So to create any program, what we need to do is we need to click on the device, go to add object, and then we will click on the POUs. So this is the POU where we have to click. When we click, it will give us to write the name of the program, and then uh, we have to select the program uh, radio button which is there, and you will be seeing on the bottom that we have options to select the programming language. So there we will get all the 5 or 6 language supported by the CoDeSys, and here we have to select the ladder logic. We'll give a name. By default it comes as a POU, but we can write any different names. So let me provide the name here and be sure that we have to select the program. Okay, and then add. Then the program will get added. Now how we start the programming in this. So to start a programming, we need to first create the variables. So variables, you have the two views here. One is the text view, one is the grid view. So in order to add, we have to click on that add, and then we can select which kind of variable it is. So as we have seen in the previous video, we have different kind of variables for what it is used. So based on the requirement, we will provide the variable name, variable type basically. Uh, so it will define the scope of that particular variable, whether it will be input, output, or local variable. So let's create it as a var, which means it is a local variable which will be used mostly inside the program itself. We will define a name. So by clicking there, we can change the name. Once we change the name, it will give you the pop-up that wherever it is getting used, it will get changed. So it will help that if whenever we are changing the names, it will show you that message, and everywhere where it has been used will get changed. Then we have the option to select the data type. So we will go to input assistance, and can select what kind of data type it will be from the different options which we have. Okay, so whether boolean, real, integer, even the date time, so those all will come there. Then we have this to describe about this particular variable, we have to put in the comment the description, uh, which will provide the description of that particular variable. So when we define a variable, we give that for what exactly this variable do, so that we define a description. So that is how it will be. Okay, so now let's create another variable, and when we create, okay, so we are getting here the error. So why this error is coming? This error is coming when we try to create a new variable, so it shouldn't happen, right? So why it is coming is because our cursor position. So if you read the message, it says that it has to be on the correct column, where the cursor position has to be on the correct column. So it is on the left side of the rail. So the rail, after that, if you click, it will allow you to start creating the new variables. So that we have to keep in mind. Sometimes we get lost, and this error will be very irritating. So let's create another variable and provide all the description. So after providing, I'm just changing the description as to, so okay. Now we'll start creating variables to go for the first program. How we can start writing in the ladder logic. Okay, so I have given two as var1, var2, and another is var out. So which will be something for two contacts and one coil. Now this is the rail or the network where we have to start writing. So we can do it from the top also when we have all the most of the required components placed above on the in the menu bar side, and then also on the right hand side we have all the, in the toolbox it will show all the components which we can use to write a program. So let's drag and drop from the left from the right hand side of the toolbar. So if you see, I am able to do it from the both, correct? So we can create as many as contacts from. So now let's, in order to, we have to also give the output, correct? So let's insert on the network, and then we will put the coil. So the coil will get appended and it will come on the right hand side, most right hand side and of the rail. So we can drag and drop the variables, and we can put it on the uh, contacts and the coil, or wherever we have whatever the elements we have there, we can directly drag and drop the variables. So it will help you to not, you can do it by typing there also, but drag and drop works very pretty easy. Now if we have to make a parallel branch, or we have to put the contacts which is there in the rung itself on different sides, so these are the different options which is given. So when you click and drop like this anywhere, it will show that whether it has to go before or it has to go after. If you have to go on top and bottom, then you have to click on that top and bottom arrow, which will make this contacts on, either make a parallel branch on bottom, or what it will do, which one is you are dragging and dropping there, it will make it to the up. So as we saw here, so we drop it on the bottom arrow, so that it will go to the bottom. If you drop it to the top, it will go to the top. So this is a parallel branch created. So now let me provide the variable at two places also. So after providing the variables, we can also do negation and everything by right clicking. So these are the different options from where you can actually do. So you can do it by right clicking there, you can do it from the top, you can do it from the right hand side. So these are the different places from where you can make the rung, or you can change the component whatever is present there. Okay, so I have defined two NC contact. So NC means when it is normally not energized, so normal condition of that particular contact. NO is normally open. So when it get energized, NC become open and NO become closed. Okay, so this is the branch. So when we click create a new branch, if we push there, then it will remove other, and so we need to be careful when we are doing all these things, but that will come when we start working on these things. Pretty handy it will come. So let me start my so okay, it is started. So I will go and see it is showing here. So okay, we have here because the latest CoDeSys version are asking for username and password in the device also. So I have given my username and password, but that can be changed. So you have to go to the change runtime security policy, and if you see here, we have here different option. I will select optional user management. Okay, so after selecting optional user management, what we need to do, we need to reset the origin. If you don't want this username and password to pop up, and when we do the reset origin, uh, after that it will not ask you because we have given option as a optional user management. So these things are configurable. Okay, so let me download. So once it get downloaded, it will be by default go in stop mode. So not the PLC, but only in the IDE, and then we have to click on the play, and then it will go in the run. So once it goes in the run, it should start working, correct? But it will not, as you see, it is still highlighted in the gray. So it has to be in the black to get run. So we have to call this in the main program, or we have to put that in the main task. So either way we can do. Okay. So I will call that in the PLC program. How we can call a program into another program is we have to type the, we cannot drag and drop. So it is not supported. So we need to type the name of the program ending with the small bracket and the semicolon. Okay, so once we give this and download again, so as it is a minor change, so it will give you different options: online change, login with download, without any change, update the boot. So when we do the login with online change, then what happens, it will download for a particular time, so till the PLC is not getting reset. Once the PLC stop and it get, what it will do, it will get reset basically, because it was just an online change, so it has not updated the boot project. So once we go to now to the program and see the run, you can see that the at the top we had two NC contact, correct? So once the program started, the rail, if you see, the rail is energized, and when rail is energized, it is creating the whole flow path in the run itself. So you can see this with the blue line, the all the contacts from where the flow is passing, it is actually showing particularly. Okay, so we can prepare the value and give the command. So shortcut is Control F7. Control F7 is the shortcut to prepare the after clicking that, when we see Control F7, it will write it to the particular value. Okay, so let me do some changes to show a different behavior. So I have removed one contact, and then let me download the program. Okay, so now you see it is showing in the black because the rail is energized by default, but my the first contact is in true condition, means it is open. So now let me make it false. So once it is false, you see the flow, the whole path is energized from the top path. Now in order to make it again, if we make it false, it will be black color. Okay, so these are the different behaviors when we do on the run. So when it is energized and everything is good, coil is getting the final output, then it is the whole will be in the blue, and other in another case it will be remain in the black. Okay, so let me take you to another part. So let's create a function block. So process will be same. We have to go till the POU, and then we have to select, instead of program, we have to select the function block. There will be a lot of things get highlighted, but those are a little on the advanced side that we will cover later. So let's start from the basic part. So this is the function block part. Here also we can select the implementation language, whether it has to go in ladder or different one. So let's give a name and click on add. By default ladder is selected. If it is not, you can select the ladder. Okay, so the structure of the function block will be almost the same, but if you remember, in the program only the var and end var comes, but in function block it will come with input, output and var. Why? Because function block we need to provide, uh, by default we need to, it is asking that maybe you need to provide some input, you will get some output from the function block. That is why the basic structure is made like that, but if we don't want, we can change it based on our need. Okay, so let me define some input variables. So I'm just trying to create a small program for the pump start and stop. uh, so how exactly, when we give a command from the outside, how exactly the function block will work for the pump part. So I'm just giving I'm giving it with a prefix that this is a set. This is set means we are giving a command there, so just some prefix I'm adding. So, and a suffix as a cmd means the command. So that is up to every individual how they write the naming convention, but the naming convention should be a little knowing that we should be able to understand, but that is all up to every individual. So let me almost define the different sections. So two variable as input, one var as output. So very basic. Okay, so all the three variables are defined. So let me create, uh, so I'm not defining any here. So let me create the rung now. I've saved it. Okay, let me put the contacts. So I made it NC. So stop, and on the NO contact I'm putting the start. Okay, now let me put the coil, which is the output. So after putting the coil, I'll just assign the variable start stop out start stop pump in the coil. So this is a very basic function block get created. Why we use function block? So that once we create a function block, we can instance it multiple times. So like we have one pump, we can write the program. If we have 10 pumps, then whether we are going to write the 10 times the same logic? No. So uh, we will instantiate this particular function block multiple times there. Okay, so just I'm trying to make this some changes. Okay, so after defining all the things, let's go back to call it, how we can call this particular program anywhere. Okay, so one thing we can also initialize the default value inside the for any variable. So let just I'm trying to show that how we can initialize this value. So this can be initialized in the initialization column. So by default, it will initialize with that particular value for that particular variable. Okay, so when we initialize it with some variables, then uh, that will get when we call that in the program, it will be initialized basically. Okay, so now let me go to the ladder program, and there I will try to call this particular pump function block. So how we can write, uh, we have to give the some instance name, and then the function blocks become a data type. Okay, so with that data type, that instance will be created. So that is one way of doing it. Or let me insert a network, and let me see, in the POU we will have this showing. So we cannot drag and drop from the left hand side, but we can drag and drop from the right hand toolbox. So that we can drag and drop here. So it will create an instance name, but it will ask us to create the instance names, correct? Now whether we want to create using that or by writing by our own, both options are there. So let me put the name which I have given, and by default it will come with some enable bit. So there are two kind of blocks where we can define. So either you can even remove this particular context also by right click and delete, so it will be a blank, so always enable, or you can give there as a true. So both options are there to do those things. So let me just copy and paste the variable here directly in the program, so it will be easy to for the mapping part. I will use the same variable names. So now let me put this variable, assign this variable to each uh, function block variable. So start, stop, and the out. Okay, save it and go online, login, login with online change. Now you can see that the block is getting executed, and when we give start command, maybe I will get the output, because stop is negated inside, so it is NC contact, it is there. So by default, till we don't press stop, the output will be there, and once we press the stop become true, uh, that output will go off, even the start command is there. So that is the basic feature for the pump, that start, stop, and how we can start the pump. So basically here I was trying to show how a function block can be developed and how it can be called. So now let me show you, we stop the PLC, and now let me start it. So as we did the online change, correct? So what happens when the PLC gets stopped? When we try to go online after the PLC restart, it will again ask that this the program which you are using is the with changes, so whether you want to, that's, and that's get helped by when we have this login with download, so it update the boot project. So after going with login with download, it will not ask if we even stop the PLC. So let me show you that part also. Now start the PLC. There is no change in the code right now, so it will go online directly. So it happens in every PLC like that. So that is the same behavior it is here also. So these we can even change or prepare the value from the variable direct there also. Same thing what we were doing from the rung, in the rung. Okay, so from there it is the same command we have to use, control F7. So control F7 is a shortcut. So sometimes in some laptop it will be control function F7 or control F7, so that how the F7 is getting called. Okay, so let's go to create. Let me check. So we will create now another. Okay, so let's create another kind of POU, which is a function. So we developed program, we developed function block. So let's go to the third part, which is a function. So function basically, it also act as, we can create a function and we can call uh, multiple times, but function doesn't retain any value because it doesn't have any memory. Okay, and in the function when we are creating, we have to define what kind of return type it will be. Okay, so we need to provide that, otherwise it will not allow us to create the function. So that is a basic difference between the function and the function block. So function block has its own memory, so when we go inside, it will show exactly how that particular instance is running. But for the function, it is, when it is called, it get executed, and then there's no memory for that. So we will not see exactly when we go inside what is the state of that particular function at that time, because it is getting executed for all the calls where it has been done. So if you see the structure, it remains almost same with the function block. So it will have input, output, var. So I'm just creating the same logic here. So it is pretty easy. Or even what you can do is, if you see the name at the top, it's function defined. So you can duplicate the function block if you want to do make that as a function, and from the function block you can change that to a function. The name on the top which you are seeing, if you change that, it will become from function block to function. That is very easy to do that in CoDeSys. So let me create uh, different variables, so it will be easy to do the differentiation basically. So now let me create three another variables. Okay, let's assign all these variables to the function. I will, if you see, it is giving the return type which we had given. So there are two ways in which this function can be utilized. So either we define an output variable, or what we can do is, we can, instead of defining an output variable, what is the return type, normally how a function works, we can define that at the return type itself. So that is why it was asking for the return type, what variable you will be returning. So based on that, we can define the return type. So let me show you the differences, how exactly it works. So right now we have used inside the logic the output in the, which is getting worked similar as function block what we had. Okay, but the return type is not getting executed. So that is okay, let's first show you the function. So it is working pretty in the similar manner as the function blocks. Okay, so there's no difference if you see from the external view. Okay, so why exactly this particular, let me create, drag and drop another one and create another set of variables. So all the variables, okay, I have just put that as a second, and let's start assigning them to each. So once we assign it, it is done. Now let's again, let me, okay, this one, I'll make it again true. Save it and download it. So I'll get login basically. So if you see now, let's toggle the bits. So I make it true, and second one also I will make it true. So so if you see, both are getting executed, but if I go inside, I do not see any kind of details here, because uh, at that particular instance which function is getting executed, that is why it is not giving any more detail inside. But if you go inside the function block, you will see the exact status of each bit inside that. Okay, because it has its instance and it has its memory. So function blocks consume more memory than the function, so we need to be pretty sure where we have to use function and where we have to use function blocks. Okay, so now as we had this bool as return type, correct? So how we can define this so that the return type should work? So let me show you that. So what exactly we need to do? We need to actually assign to this particular function block type. So let me create a branch for that and will assign. So by this return is different, we cannot use this, so because it is little confusing, correct? Return type and then the return. So I will take this in more details. So this return, if we put like this or anywhere, it will not work. So we have to be pretty know that which one, how we have to exactly define. So I'm just showing that by putting this return, it will not exactly do what we want. So this is, there's a difference between return type and the return. So what we want here is the return type. You see, I gave command, but it is not giving me the exact what we need. So let me no, let me remove this and let me show you how exactly it will work. So let's go to the function, and so instead of in the coil, if you see, we have defined right now the out variable. So that is why we were getting in the out variable. So let me create another coil there, and how we define the variable is we have the function name. So just drag and drop that function name here, and that will do the work for us. So instead of output variable, we can also define the function name, and as the return type is boolean. So let me start the PLC. It got stopped because it runs into our demo mode. So after 2 hours, it will get stopped. So let me download. And now let's go to the ladder program and we'll see the result. So once we give a start command, we see uh, on the both the return type and the out variables both are getting now energized, because we have assigned also the return type, uh, because the function was called, and and uh, it is getting assigned. So okay, so yeah, we can also do the change the value of the variable by right clicking on it and going to change the value. So write the value to the variable. Okay, so we have option to force also, but we will force is that everything will get forced, even whatever value is coming, that will get forced with the value which value. So we should use mostly the right, and if you have to force sometime, then you can use the force. So so this is how you are able to see that the function, the return type is actually now start working. So we need to be sure that how exactly we have to give. So either you can use the output variable, or it is better to use the function, so the intent of the function remain what it is for. Okay. Okay, so now let me show you different the basic or the major uh, elements which in ladder we can use. So like as I was showing you the return, correct? So we were confused with return type and return. So what exactly the return do? So that we will see what exactly there's element called jump. So these are the basic thing which I will be now doing. So let me first go for the return. So when I put a return in any particular rung, what have so this is how we can put that drag and drop at which rung you want to, the return to be happening. So what return do that it will not execute after that particular rung itself. So it will not go to the next rung. It will return from there to the first, or the to the initial state of the program, or to the function block. So for example, right now let me change the value here. So for the run 2, the pump 1, the function block, the value are changing, but if I go to run 3 and change, it doesn't. So that is what the return is doing. So it is returning from run 2 itself. So let me show you in the debug mode. What is debug mode? So in the debug mode we can debug our whole program. So just right click, toggle the breakpoint, and then you will be in the debug mode. So if you see when I click, oh, okay, let me. So you see it is going from one, it is not going to the rung 3 itself. It is, if you see return, and then it is returning to the first. And I have given a breakpoint at rung 2, so that is why it is from 1 it is directly coming and breaking at that particular rung. So let me toggle the breakpoint at rung 1 also. So it will, I will show you how exactly it get executed. Return, it go on the bottom, then return in the main, then first rung, and then to the second rung, and then execute all the blocks or whatever the blocks is there, and then so it goes in that manner when we use a return. So disable the breakpoint and click F5, or click on the play button on the top. So it will start executing in the normal way without a debug mode enabled. So this was one of the major features of the elements in the programming is the return, how we can go from one to another. Okay, now okay, let me show you another thing. So I will assign a variable here. So once we assign a variable, what I'm trying to show you here is that if that particular rung is not enabled basically, okay, so the return will not be happening. It will go to the next rung also, because that particular rail itself or the rung itself is not enabled. So it will not come in execution. So basically what we can do is, based on some condition, if we want to return from that particular place, so we can provide that logic. Okay, so once we enable, it will return from there, it will not execute, but when it is disabled, it will execute as expected. Okay, so this is all about the return statement. Now I'll walk you through a different set of command, which is jump. So let me go offline and go in editor mode. So I will put here a network for the jump. So here we need to define a jump level, where exactly
when this particular run get executed, where it has to get where it should jump. So once we have given here a label as network 4, we need to also define a level in the sum of the rung where it should go. So this assignment we can try, but this doesn't work as it needed. But so okay, let me delete this first, because we need to give a level, not the assignment we have to do. So right click and then click on the level. So once we click there, it will give me option to insert a level, and we need to provide the same name what we had given, so that it understand where it has to go. So I have given here the same name. Okay, so what we can do, let me put a, so that we should be able to enable or disable this particular thing when we have to see the how execution flow goes on basically. So from here, let me save and download the program. So all the download I'm doing is online change. Okay, so let me show you the difference. So right now the jump is not enabled, so jump rank is not enabled, so it is, but so I just enable it, make it true. Now if you see, the network 3, which was the pump on function block, is not getting executed even if I change anything. So what exactly it is happening, we are bypassing that particular run. So let me show you in the debug mode. So you see, when I go to the next step, it is going directly on the network 4 where the level has been defined. So this is the actual work which, when we define the jump statement, it will go directly to a different to the rung where the label has been defined. So let me remove the debug mode, and I'll disable, yeah, and disable this, make it false. So jump rung, I will make it false. So then we will see that once it is made false, it is going to the next rung also. So it is not jumping, but it is executing in a manner from top to down. So let me remove this debug also. Yeah, so now it is executing in a similar manner, means how it has to. So when we enable and when we disable, this is how the execution flow changes. Okay, so now let me go offline, and I'll show you another command, which is execute. So let me so what exactly this execute functionality do. So we write the code in the ladder logic. Okay, so this is ladder logic. So execute actually give us, for example, when we have some complex equations, or any complex logic which we need to write, we can write that also in this execute block, which supports, which is like a structure test in which we write all the program. Okay, so whatever the statement we write here, whatever the equation we write here will get executed, and it will help us to not write much ladder logic, means not just to summarize all the thing inside one block itself basically. So I'm just putting the same brief of command, like start stop with the pump, uh, to just showcase how exactly it works. So let me map all. So so in order to, there's a shortcut to get the variable, is that is what I'm trying to show here, is one mention here that control plus space will give you is a shortcut keyboard keys to get into the variable directly from here. So if whenever we say put some letters and then control plus space, then it will show me all the variables with starting with that particular letter. Okay, now, okay, so the command is written, all the statement what we wanted. So now let me execute the code. So in order to execute it, we need I will be, let me save and download again. So I'll make this disable because it is the same variable I have used. So so that it will, I'll show you, means the variable will get executed, but the it will not get executed from the network 3. Okay, so if you have seen the variable, the out variable which was there, it was true, even though the pump one logic was the rank was disabled because enable was false. Still the output got executed, so it is getting executed from this particular logic. We cannot put this in when we go inside and try to put in debug mode, it will not go. So if you want to put the debug, then we have to click outside, and then the same way how we do toggle the breakpoint, it will happen. Okay, so it is coming here and getting the variable executed based on the command. Let me disable it, and it will go in the flow. So all other type of command we can find in the ladder elements. So all the elements will be present inside it. So like T on, T off, CTU, counters, up, down, timer on, off. So all these are present there. So whichever we want to utilize, we can use them, put into the rung and execute it. So based on the logic needed, we can take it from there. So CoDeSys also has a good help file. So for each kind of uh, elements what we want to use. Okay, so let me show you one another feature. So when you are writing a program in CodeSys in ladder FBD, okay, so we can toggle between ladder to FBD and FBD to ladder. So there's an option when you will be go into any of the program which is written ladder, you will see on the menu bar as FBD, LD and IL. So we have to click there and we have to say show it in ladder. Once you click there, it will show all the FBD into ladder. When we go and say to view in ladder, okay, so right now I'm in FBD. So if you see, this has got changed to ladder logic. Okay, and when we are in ladder, same thing, we go to view and click in function block, then the whole program will get changed to function block. So this is one of the cool feature which is there. So you don't have to write the logic in two different way. So you write in one and maybe it will, you can show it in different graphical form. So that's all for this video. See you in the next one. Thank you.